Hello, this quick video is going to be about the topic of confidence intervals. What is a confidence interval? When do we use it? And finally, how do we calculate one? What is a confidence interval? Confidence interval is essentially a way of statistically trying to figure out what a population mean, mu, is, or what a population proportion, a pi, is. And we typically are going to do this in a situation where we want to know what that number is, but it's infeasible either economically or in terms of time or manpower to actually calculate those numbers. So let me give you a couple examples just for a bit of flavor. So this is an example for a population mean. Let's say that we work for a pharmaceutical company and we distribute ibuprofen. And we're going to sell bottles of ibuprofen that have 50 tablets on each. And on each of these bottles, we're going to write on the side, right, there's 50 tablets of ibuprofen in here, and we're going to sell them. Now, why do we care that there's going to actually be 50 in there, right? Why not give them 51 or 49 and who cares? Well, if we continually give people more than 50, we're simply giving product away for free. That's not a very good way to make a profit. And if we continually put less than 50, right, if we're putting 49, 48, then we run a very large risk of either being sued by a customer who might say, hey, I'm going to count, and guess what? There's not 50. Or a regulator or a regulatory body who might say that our labeling is incorrect or we're deceiving our customers. And generally speaking, lawsuits are an unprofitable way of going about your business. So we want to be pretty sure that there's 50 tablets of ibuprofen in each bottle. For the case of a population proportion, let's say that we're an advertising agency and we just came up with a brand new advertising campaign for some product. We want to know how the population in general, normal people like you and I, are going to react to this advertising campaign. Are they going to like it? Are they going to dislike it? And so our proportion that we might be interested in is what proportion of people are going to view this advertising campaign and have a positive impression of the product after viewing it. Now, in both of these cases, it's either impractical or even impossible to figure out what the true number is. If we were going back to the pill case, right, we could conceivably hire a person or a whole lot of people to, every time a bottle is filled by our machines, pour out the pills, count them out, make sure there's 50, put them back in, and send it on its very way, right? That doesn't seem to make a lot of sense, right? That would just be too costly to do. In the case of the advertising, it's probably impossible to actually track down every single person in the country who might be a potential consumer of this product, right? How are we going to know who's a potential consumer of the product? To have them watch the video, to give us their opinion of the video, this isn't something that's going to work. And to be quite honest, let's say it is a bad campaign ad. Now what have we done? We've shown everybody this bad ad. Well, that's not going to be very good. So we want to figure out what these parameters are going to be in the population, but we don't feel like we can look at the entire population to find out what the parameters are. What we're going to do instead is collect a sample. We're going to go out and grab 200 bottles off the line and count how many pills are in each bottle. Or we might interview a focus group of 200 people or 800 people, or do a poll of 140 people, right? Something like that, to calculate a sample mean or a sample proportion. Now this sample mean or this sample proportion is going to be our very best guess as to what the population parameter is. But is that good enough? Is that guess, is that sample mean or sample proportion, is that good enough? And the answer is no, because we need to consider a margin of error. Let's say that we run this campaign, or we make these ads and we're about to run the campaign, and we go out and we get a focus group. And let's assume that in the general population, 50% will like it and 50% will not. Well, it might be the case that when we go out and we get our sample group, that half the people will like it and half the people won't. But it doesn't necessarily have to be the case. It might just be that we randomly choose a larger number of people who like our campaign than is actually existing in the general population. All right, so just an off-the-wall example. Let's say that we're interested in knowing what the average income of American citizens is. So we get a random digit dialer and we dial 1,000 random phone numbers, and we dial some people who are doctors and some people who work in fast food and some people who are accountants and, you know, all walks of life. But we just randomly, right, because this is a random dialer, call Kobe Bryant. And Kobe Bryant, we say, hey Kobe, how are you doing? And he says hi. And we say, how much do you make this year? And he said, oh, I made $52 million. Well, hold on. When we take this $52 million and we, think about what that does to our sample mean, that's going to increase our sample mean by $52,000. And there's no way that the average income in the United States is something like 120, 130, and 120,000, 130,000, I'm sorry. Why did we get this number? Well, because somebody we interviewed in our sample really blew our sample out, right? It made our sample unrepresentative of the population, and we need to take into consideration the fact that our sample may not in fact be representative of the population. It might be a little bit off. And that's what the margin of error is all about, is saying, all right, we are cognizant of the fact that we probably don't have a sample that is perfectly representative of the population. So we're going to put a margin of error around our estimate. And once we put that margin of error around the estimate, we're going to feel a lot better about the number that we calculate. So instead of saying, oh, in the case of our pills, we counted the number of pills in 128 bottles, and on average they had 49.8 pills in them, so hey, we're not doing the right thing. We would calculate a confidence interval, which would say, for example, we are 95% confident. Our bottles on average contain between 49.4 and 50.2 pills in them. That would be the sort of thing that we can do. So here's another example, a more formal example. Let's say we work for a bottling company, and the label on your bottles claim that each bottle has 12 fluid ounces of drink in it, right? Now again, I give some examples of why it's good to have exactly 12. If you overfill your bottles, your costs are going to be higher than they have to be. If you underfill your bottles, you're going to make your customers upset, you're going to lose some goodwill, you could get sued, the regulators could come and crack down on you. None of these things are generally going to be a good way to make a profit. You want to get 12 ounces in each one. Again, measuring every single bottle is going to be impractical in terms of time, in terms of money. So instead, we're going to conduct a random sample, measure the amount of beverage in each of the containers, and then use our sample mean and our sampling standard deviation to calculate a confidence interval. So let's say, for example, we find the sample mean, X bar, is 12.02 fluid ounces. This isn't 12, but is it close enough? What we're going to do is we're going to use our data to construct a margin of error. So we're going to talk about in just a few minutes how to construct or calculate a margin of error. Let's assume that we calculate it at 0.04 fluid ounces at the 95% confidence level. So that would mean that our 95% confidence interval is between 11.98, that is 12.02 minus 0.04, and 12.06, that's 12.02 plus 0.04. So, how do we calculate a confidence interval? The exact method is going to vary based on the type of data being examined, but the general methodology is constant. We're going to take a point estimate, and we're going to plus or minus that with a margin of error. What is a margin of error? The margin of error is simply our critical value multiplied by a standard error. Now, the critical value is going to come out of any sort of probability table or something like that. Here we're going to talk about the z distribution and the t distribution, and the standard error is going to have a little formula associated with it. It's not terribly difficult to get our heads around. So what are the different types of confidence intervals that we can see? The first of these cases is the confidence interval for mu, a population mean. And in this case, we're going to assume that we know what sigma is, where sigma is the population standard deviation. In this case, our point estimate is x bar. Our critical value is going to come from the z distribution, and our standard error is the population standard deviation divided by the square root of n, where n is our sample size. The next case is if we have a confidence interval for mu, but we do not know sigma. We do not know the population standard deviation. In this case, the point estimate remains the same. It's x bar. But instead of using the z distribution, we're going to use the t distribution with n minus 1 degrees of freedom. And the standard error is going to be s, which is the standard deviation for the sample divided by the square root of n. Finally, we've got the case of the confidence interval for pi. The confidence interval for pi, we're going to use p as our point estimate. P, again, is our sample proportion. Our critical value is going to come out of the z distribution, and our standard error is going to be the square root of p times 1 minus p divided by n. And it's really that simple. It's a simple matter of knowing what 3 elements you need, plugging in numbers into each of those elements, and solving. So let's return to our bottling plant example, and we recall that we said that each of our bottles has 12 ounces in it. So assume that we collect a sample of 100 bottles. And in those 100 bottles, we find that the mean fill level is 12.02 fluid ounces, so that is going to be our sample mean. And we have a sample standard deviation of 0.2 ounces per bottle. We can use this information to calculate a confidence interval. Now, the first thing we need to do is ask ourselves the question, which of the equations do we need to use? Well, we're looking for a mu, right, because 12 fluid ounces is a number, and we don't know what the population standard deviation is. Generally, you don't. So we're going to use the standard deviation of the sample instead. So we're going to use the middle equation from before. This is the equation we're going to use. Confidence interval is equal to x bar plus or minus a critical value from the t distribution with n minus 1 degrees of freedom multiplied by s over the square root of n. Now, the previous slide had all the information for x bar, n, and s. We can just plug those numbers right in. Now we need to find a value for T99. Where are we going to get T99 from? We can use a t-distribution table like you'll find in just about any statistics textbooks. There's dozens, if not hundreds, of t-distribution calculators online. Excel has one built into it. However you do it, you're going to generally find that T99 is equal to 1.98. So we simply plug that number in, and you can see in the equation on this slide that that's exactly what I've done. We can do the math, and we can calculate the margin of error. That's 1.98 multiplied by 0.2 divided by the square root of 100 is roughly 0.04. So our confidence interval is 12.02 plus or minus 0.04, or mu is somewhere between 11.98 and 12.06. These numbers match the hypothetical example from before, and the way we interpret that number, the way we interpret that confidence interval, is by saying that we are 95% confident that the average bottle has between 11.98 and 12.06 fluid ounces in it. So now we've reached the end of our video on confidence intervals. Hopefully you've learned in this video what a confidence interval is, how to calculate one, why it's useful to calculate one, and how to interpret the results or how to read what a confidence interval is telling you. Thank you.